discuss general structure, how we are going to proceed with this course. And I think I have not presented the screen. So is my screen visible now? Can anybody raise the hand and let me know if the screen is visible? Okay. So in last class, we discussed the general structure, like how we are going through this course. So in general, we will have some function which we will be having some value at some given instant or given point, and we want to plot the whole trajectory. So in today's class, we will discuss the. So my voice is echoing. Can anybody close the microphone? Yeah. So if anybody have a question, he can raise the hand and then unmute it, and then I will answer his question. Try to answer his question. So in today's class, what we will be doing, so we will take a small problem and see how we will proceed with it, and how we will, like, what do we mean by what we were discussing. Okay, so in today's class, we will take the example of motion of a particle in a circular motion. So today's class will be, so in today's class, what will be the agenda? So it will be the particle motion on circular track. Okay, so a particle will move on a circular track. So what we will discuss is, first we will get the equation of motion. So what do we mean by equation of motion? You will know so on. So, and then once we get the equation of motion, then we will try to simulate it in MATLAB. Okay, so this will be the agenda for today's class. So let me quickly take the example and see how we will go through it. So let's take a frame and say this is x-axis and this is y-axis, and this is a particle, say p particle, and let r be its position vector at any time t. Okay, so usually I will write this r of t simply as r, but you should know that this is function of time, and obviously this r will have two components. One is x of t and one will be y of t. Okay, so this much is y and this much is x. So I can write this r as xi plus yj. So where I is the unit vector in x direction and j is the unit vector in y direction. So till now it is fine. So now the second thing which we know about this particle is that it is moving on a circular track. Okay, so we know that it is on a circular track. Then someone may ask that, so why we are going to calculate its trajectory? If we know the trajectory is circular, then what is the fun? So my the thing is that we want to find r as the function of time. Although we know that the trajectory is circular, but we don't know at a given time where the particle will be. So our purpose will be to find the r as a function of time. So if you know what is the r as a function of time, which in term means x of t and y of t, so you can, for example, at a given time t, you know what is x, you know what is y. So, so you, let's take this point is the corresponding point, that is x of t and y of t given at some given point. Okay, so you plot it here, and at next time it will be here, then at next time it will be here. So at each time, if you are able to find out what is x and y, so you can plot this thing. Okay, so but now how to get it? So what we will do next is, so we know in circular motion. Okay, let me take the same picture. So let me take the same picture. So in circular motion, we know that the particle motion, that is the velocity, is always perpendicular to the radius. So I can say, let's take the velocity of this particle. So let us say this is velocity. So what we know from the circular trajectory is that velocity is always perpendicular to this r. Let me call that perpendicular to the r. Let me call this as n unit vector. That is a vector which is perpendicular to the radius vector. Okay. So now velocity will be in the direction of that vector, and there will be some magnitude of the velocity. Let me call that velocity magnitude as c. So the velocity will be some c times n hat, where n hat is the normal uh, to this vector. Okay. So the next thing is, okay, so we got this. So velocity at any time is nothing but c times n hat, where n hat, c, at this instant of time when particle is here, n hat is this. When, for example, this particle will reach here, so r will be this and n hat will be in this direction. So n hat in itself is function of time. Okay, so so we got this velocity, which is some c of n hat. So we know now, next to what we know is that dr upon dt is v. That is the derivative of this position vector is velocity. But what we want r. So r we can get. So next we can integrate this dr upon dt to get r of t. And integrating dr upon dt means integrating velocity. That will be r of t. Okay. And what is this v? This is cn. So basically you are integrating cn hat of t, and this will be your r of t, which we are searching for. So we need this r of t. So we will get this r of t once we know what is integration of this thing. Okay, so this is the new problem which we are now facing. So we need to get this integration. Okay. The next thing is, what is this n hat? Okay, so what is this perpendicular vector? So we can always write. So I can always write, since n is a unit vector, so I can write any unit vector as cos of theta I plus sine of theta j. Why? So let me take this as x-axis and this as y-axis. If anybody have any doubt in between, please raise the hand and let me know. Okay, because see, this is very important and this is very basic. I usually assume that most of the things you will be already know, but this will be the like basic when you will go through this course. If you don't understand these things, then the coming things will be much harder and then you can't understand. But if you keep track from this point, so it will be very easy for you to get those things also. Okay, so any question if you have, you can ask in between. So this is y and this is x. Sorry, this is this I cap and this is j cap. So let me take any unit vector. So let me take this vector. This is unit vector. Okay. So this will make some angle theta with the x-axis. So I can write this as unit, since this is unit vector, so its magnitude will be 1. So its x component will be 1 cos of theta, and its y component will be 1 sin of theta. So that is why we can always write any unit vector as cos of theta I plus sin of theta j, where theta is the angle made by that unit vector with x-axis. So here if you see this unit vector is along this, so this will make, this will be the theta, okay? And you can write it like this. The next thing is, so what is the slope of this line? That is n vector. So we can write the slope of this n vector is nothing but sine of theta upon cos of theta. Okay. What is the slope of this r? So r, let me write this r. I think I have already written down. So yeah. So r is what? It is xi plus yj. So what is the slope for r? So slope for r is y upon x. Okay. Now we know this r and n, these are perpendicular to each other. And we know when two lines are perpendicular to each other, the product of slopes, so product of slopes m1, m2 is -1. So m1 is the slope of this r, that is y upon x. m2 is the slope of n vector, that is sine theta upon cos theta, and this is equal to -1. So from this I can get, and this, oh, okay. So this I can write as sine theta upon cos theta equal to -x upon y. And that is nothing but tan theta equal to -x upon y, which is equal to theta is equal to tan inverse -x upon. I think I have written wrong, but one has pointed it out, or I have written right. No. Okay. So this is the theta. So any question till now? Am I too fast or too slow? You can. Am I too fast? If I am fast, raise your hand so that I can get. If I am fast. If I am slow, raise hand. I will increase the speed. And if I am slow, someone has raised a hand. So am I slow? Then raise your hand again. Am I fast? Yeah. Okay, let me slow down some. Okay. So let me again explain what I was trying to say. So our problem is that we want to simulate the particle which is moving on the circular track. Okay. So the first thing what we did so the particle will be at some position and we call that position as r of t. Now this particle is moving in a circular track. So we know the velocity will always be perpendicular to the radius vector or the position vector. And we say that let n hat be the normal vector to the position at any instant of time. And this n hat will continuously change. It will be the function of time. Okay. Theta is function of time, that which implies that n is function of time. So next, what I did, I wrote this information, that is v is in a direction of n, and this c is some scalar quantity, okay, which will give the magnitude of the speed. Okay, your direction is there, but we don't know the word magnitude. So c is that magnitude. Okay. And then we use that velocity is nothing but derivative of position. So I wrote dr upon dt is equal to this v. And then I say that I need r, so I will integrate this. So I integrated it and I got R of t. Now I know this is nothing but velocity, and velocity is given by this Cn. So integrating Cn, we will get R. Okay. So if we want R of t, the only thing we need to do is that we need to integrate this term. Okay, and I have not integrated it. The reason being that we will do it by some other means. But the thing is that I hope that you understand till this point that we have to integrate this thing to get R of t. Okay. And the next question was how to get this n. So what we did is that since n is a unit vector, so we can write it as cos theta I plus sin theta j. Because if you find the norm of this vector, or the magnitude, we call it as magnitude of this vector will be cos square theta plus sin square theta, and that is 1. So this is a unit vector. Okay. So we can always write a unit vector like this. And then we know that if this is a unit vector, then what is the slope of that vector? It is y component upon x component. So y component upon x component. Similarly, the slope of this slope of r vector is y component upon x component. Okay. But I know that R and N are perpendicular to each other. So there the product of slopes will be minus 1. So what was the slope? Y by x. What was this slope? Sin theta upon cos theta. And it is equal to minus 1. Okay, using this information, I found out theta, which is tan inverse minus x by y. So from this, what we get is that given we know the R of t, which in term means that we know x and y, we can find theta. And if we find theta, that means we are able to get n. And if we are able to get n, then from this equation, we know n of t, and we can integrate it to get r of t for next time. Okay, so this is how the things will go. So now the next thing is that how we will do it. So we will integrate this term, not analytically, we will do it by numerical simulation. So let me shift to MATLAB and see how we can do it. But before that, let me do a census so that I know how many. So how many of you are aware with MATLAB? Just aware that there is MATLAB. Okay, 1, 2. Just to say that you know what the MATLAB is. I am not saying whether you are able to code in it or not. Okay, you know. Okay, so most of you know what the MATLAB is. Okay. And how many of you are able to code in MATLAB? No one. Okay. So let me assume, maybe some of you may knowing, but you are not raising the hand. But let me assume that none of you know the MATLAB. Okay. And it will not reduce anything from those who know it. So let me start with MATLAB and give you some. I have okay. I have created a mail group. How many of you have received the mail which material I have sent? So you all, if anybody among you have not given me the mail, he can send it to me, maybe through CR or from Sharik sir. He can send me the mail. I will also add Sharik sir. I think I have not added him. So I will say, so I am what I will do is I will always try to give the material, maybe assignment, maybe code, which I will be. So I will send it to you on that group. Okay. So last time I have sent some material regarding the MATLAB. So I hope you have seen it and you will be using it. So today let me give you the basics of the MATLAB. So let's start. Okay, let me give the quick view. So MATLAB has this interface. So is it visible to you that I have opened my MATLAB? Yeah. Okay. So you can see here there is one section and there is another section and there is another section, and below here there is another section. Okay. So what are these sections? So this is known as editor. So basically you write your code here, And if you have to edit it, you will edit it. That is why it is known as editor. And this is known as command window. Okay. If you want to run something, so you can type here and you can get it. Okay. And this is known as workspace. So whatever variables you are defining there, they will get automatically stored here in workspace. Okay. So let's start and see what I mean by it. Uh, so I have opened a new script. Okay. So this is a new script which I have opened. And but I will not use editor. Let me, or should I use? Oh, okay, let me go to command window. So first, let us see how variables are defined. So basically, you want some variable, maybe velocity, or you position, or something, and you want to give it a name. So you can start a name by anything, not with the numerical. You can't use the 1, 2, 3, or something like this. You have to start with the alphabets. So let me write position, Position. So this is the variable. Okay, so I have given a name to a variable, and the variable name will be position. But before doing this, I will clear. So you are seeing that there is some animation, CM option. So let me clear this all. Okay, so I will use clear all. And once I will hit the enter key, you will see all of this will be erased. Okay. So nothing is here. So our workspace space is empty now. So now what I will do, I will write position equal to. So this is the name of the variable, and I am writing it equal to 1. So I am assigning the value of 1 to this position. So I'm saying that, okay, let my variable be position and let us store 1 in this position. So when I hit enter key, you will see that position is equal to 1. And in workspace, you will also see that a variable has been stored and the value which is stored in that variable is 1. Okay, so I can also use P capital and SITION position equal to, I will write 4. I will again hit enter. So you can see that in workspace, another variable has been created where P is capital. So this means that variable names are case sensitive. If you use capital, it will be something different variable. If you use smaller, it will be something another. Okay. Next, what I will do is, if I use uh, POSITION position, so previous one, okay, which I have already defined, and let me take it equal to 6 now. So when I enter, when I hit the enter key, so you can see here in workspace position, which was 1, it is now 6. So the previous value of position equal to 1 has been replaced, and now it is not 1, it is 6. Okay, so it means the last value which a variable will see, that will get stored. Okay, previous values will not be stored, that will get replaced by the new ones. Okay, so can we use numeric in the variable name? So let me take POS, I will write short, means position, and let me call as position 1. So this is name of the variable. Okay, I am not assigning one value to it, just POS1 is the name of this variable. And let me take it as 10. So once I will hit the enter key, you will see in workspace that position 1 variable has been created, and the value which will get assigned to it will be 10. Okay, so now you can see position 1 is the variable and its value is 10. And here also you can see that is the font size comfortable or is it small? Are you able to see what is there on the screen? Sharik sir, can you, is font size is comfortable for you? Yeah, okay. Okay. So, uh, so what next? Okay, so we saw that we can use position. Let me take PO as position and 2. So this will be another variable. Okay, let me store 10 again. So again, you will see. Hello, sir. Hello.
So आप font size थोड़ा बढ़ा दीजिए इसमें.
Okay, I will increase the font size. Okay, just wait a minute. Okay. I don't think it will increase the font size, but yes, okay. Just wait a minute. I am trying to. Every time I will just forget where I have to do it. But let me see if I can do it. Preferences, command history, command window. Text display short. Tab size. Number line. Font I was seeing somewhere. Yeah. Okay. 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 So is it now okay? Okay. Okay. So okay. So let's take. So I was saying how different ways of naming the variables. Okay. So let's define. So position 2 we defined. Position 2 was equal to 10. And we saw that we were able to create this variable. Some background noise is coming and it is disturbing. Thank you. So can I define? So I am right. What I have done. So I have taken the alphabets and at the end I have taken this numeric. Can I do this? Take 2 and write position. That is second position. So this will be the variable name. And I will store, let's take 7 in this variable. Can we do it? Let me hit the enter key and you will see that it is saying that this is invalid expression. What it means is that this can't be the name of the variable. So you can't use numeric at the starting. Okay, you can use it in middle, you can use it and in end, but you can't use it at the starting. So I can have used this P70S. So this will be a valid variable name. Okay, see in workspace you will see that new this has been created, new variable. Okay, so these are all ways of using the naming the variables. So one last which I will discuss is, so let's take position of ball. So we want a variable whose name is something like this, position of ball. But if we want this, we can't use space. So what we have to use, we have to use underscores. Okay, shift and that which is their key. I can't tell you how I can show you that key, but okay, underscore, I hope you all know. So underscore and again underscore. Okay, so now this is position of ball. So this is just one variable, and we can assign some value. Let's take 2 and see. This is a valid variable name, and we have created a variable. Okay, so this is how we create a variables. So the next thing is we will see how we can get arrays. Okay, how we will get arrays. So next thing is arrays. So let's take A as basically by arrays I mean a matrix are the vectors. Okay, so let's create a matrix 1, 2, 3, and let me hit enter. So you can see a matrix has been created with entries 1, 2, and 3. So how you do it? By using scare braces and entering your entries and give space between two elements. Okay, so 1 space, 2 space, and 3. So you will get this. Okay, next let me take again A and take scare braces. Again, let me take 1. Now I will use comma instead of space. 1, 2, and 3. So again, you can see that same matrices has been created. So there are two ways. Either you can use space or you can use comma. Okay, both will lead the same matrices. So this is a row matrix. 1 cross 3 row matrix, and we call it as row vector. Okay, we can also create a column vector. So how? Let's take A equal to again scare matrices 1. Now we will use semicolon 2 semicolon 3 and enter hit. So you can see now first element and then colon takes it to the second row, and again using colon it will create the third row. Okay, so this is a 3 cross 1 matrix which is a row which is a column matrix, and we call it as column vector. Okay, until this, any question from anyone? Raise your hand if you have a question. It is nice to ask questions. If you really want to learn coding and other stuff, you have to question me. Okay. Okay. So next, let us take again A. This A is not like I am writing it as a capital. It is not necessary. I can use small and write it as, or I can use as, for example, let me call it as position again and write it as 1, 2, 3. So you can see now a position is in itself is a matrix. Maybe this represents the position of the particle, and this represents the x component of position, this represents y component of position, and this represents z component of the position. So you can use this. Okay, and okay, let me again come to A because it is very simple to write. So now let me write 1, 2, and 3. So you know the output will be a row matrix. 1, 2, and 3 will be a row matrix. But now what I will do is I will use colon here. Okay, then again I will write 4, 5, 6. Again I will use colon and I will write oh okay, only 2 I will not So what will be the outcome? So it is obvious that 1, 2, and 3 will be on same row, and then using colon, it will take the next row, and then there will be 4, 5, 6. So hit enter. So you can see that 1, 2, and 3 are in the first row, 4, 5, 6 is in the second row. So in this way, you create the matrices. So don't forget to look into the workspace. So in workspace, you can see A is a matrix 1, 2, 3, colon 4, 5, 6. Okay. Okay. So now the thing is that maybe you want to access this one, you want to access this two, you want to use this three. So how can you, given a matrix, how can you access its elements? You want some element. How can you? For example, I want this 6 element. How can I get it? So how can I get it is from the indices. So the indices for this, the index for this one is 1 row, 1 column. That is 1 comma 1. The index for this is 1 comma 2. The index for this is 1 comma 3. For this is 2 comma 1. For this is 2 comma 2, and for this it is 2 comma 3. So we can use these indexes to access the element. So now what I will write, A of 2 comma 3. So what does this mean? So it means the element of A matrix, the element of A matrix at what position? In second row and in third column. So A matrix is this, second row is this, and third column is this. So it will be 6. Okay, so let's enter the hit button and we will see if it can give us if it can return us the value 6. Okay, so you can see the answer is 6. Okay, so we could have stored this value. I didn't store it anywhere. Okay, we could. That is why the MATLAB created a variable by itself known as ANS answer. This is a variable. You can also see it from the workspace. ANS has been created, but we could have stored it. So I will store it. Let me call it as returned value, and I will. Again, what I want to store is a value at 2 comma 3. Okay. Okay. So you can see now this returned value is a variable name, and what has been stored in it? This this uh, this element has been stored, and you know what is this element? This is nothing but this element. So you can see this is the okay. Okay. Now there are a few. Uh, there are few functions you can search for those, and just what I'm trying to give you as a glimpse of MATLAB so that you can use, you can try these things, and we will be using these all these things. It is not like just we are doing it for fun. We will use these things to solve the equations and simulate the mechanical systems. Okay, so next thing is so next thing is what? Uh, okay, so we want, maybe we want to change this. So we have this matrix, okay? We have this matrix. We want this matrix as it is, but we want to change this element maybe to 50. We want here it should not be 5, it should be 50. So how can we do it? So what we will do is we will again go to this element. What is this element? This element is in second row and in second column, and we want it to be converted into 15. So we will assign this position as 50. Okay, so so now let us see what A is. So now you can see this element has been changed to 15. Previously it was what? It was 5. What we did is that we changed this value to 15, and then when we saw this A matrix, it was 1, 2, 3, and here it was 50. Okay, so by this you can access the elements, you can change the elements. Okay, uh, So there is a very special thing, a special way of accessing the whole entire row. For example, you want to access this whole entire row. You want that we should get one given a matrix. Okay, for example, okay, let us give another example because maybe this is looking very small, simple to you. Let's take another example and say this is 1, 2, 3, 4, 5, and 6. And oh, sorry. Uh, uh, okay, so how I do it is that I press this up key and this will pop up here. Okay, whatever is the previous you want. So I just press the up key and it will come. Okay, so next, so this is the first row. What is next row is, let's take 10, 15, 20, 4, 0, 7. Okay, elements are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let's take one more row and let's this is -1, -2, -3, -4, -5, and -6. Okay, so we have created a matrix like this. So you can see this is the matrix, which is a 3 cross 6 matrix. And we want for example, we want elements of first row only. So how can we get these elements? So what we will write is, so first row elements. Okay, so this is the variable name which we want to give, where we can store these values. Okay, okay, let me first cut it, and because maybe you may get confused with it. Okay, let's just retrieve the first row elements. Okay, so I will write B. Actually, I want this from you, but since you are not on the mic, so I have to assume that you are getting it. Otherwise, I would like to answer you that what should be the output. Okay, so now if I write B of, so what I want first row. Okay, so I will write 1, then I will write comma, and I will write this colon. So what this means is that B first row and all the columns. So this is first row and this is all the columns. So it will return me all the elements. Okay, so let me hit enter. So you can see 1, 2, 3, 4, 5, 6, all the elements has been accessed. So similarly, if I write B of okay, so first, so now if I want, similarly, if you want the elements of third row, so what should I write? I should write B of 3 comma colon. Okay, so you can see all the elements in the third row has been returned. So now if I want to get this these elements 4, 4, 4, -4, that is 1, 2, 3, 4. That is fourth column. I want only fourth column. So how should I get it? So what I will write is B. Now I will write all the rows but fourth column. Okay, so this means all the rows and this means fourth column. So this will return me all the elements which are in the fourth column. And see, the answer is that 4, 4, 4. So, but in these things, see, the MATLAB in itself is creating a variable and storing it. But we can write our own variable and tell it to store in that variable. So what I will do is, so elements in fourth column. Okay, this is the name. This is the name which I have given. You can give some other name. This is not important. Okay, you can give any name. And what I will do here is get those values, that is fourth column. So you can see now, so these have been stored in what? It has been stored in this. So in workspace, you can also see that it has been created. Okay. So this is how we can. There are a lot of things. So when you will start doing coding, having fun with the MATLAB, so you will get used to it. Okay. So let me check how much more time we have. So can I take till 1? Are you comfortable with that? Till 1? So that I can simulate that whatever dynamics we have read, because I have not done that yet. If you want me to go to 1, I can, because I have started late. I think I have, I think 5 to 10 minutes, but I want it to go to 1. If you are comfortable, then let me know. Otherwise, I will finish it by 5 minutes or 10 minutes. If you want, I can go to 1 and finish the animation of circular trajectory. Otherwise, yeah, anyone among you can come onto mic and tell me what will be good for 5 minutes. 5 minutes. Okay. Okay. So, okay. So what I will do is, since I have only 5 minutes, so I will take that problem in the next class. That is the animation of the particle moving on the circular, how we can do that. But maybe I have some other stuff to tell. Okay, so okay, so let's see how we can plot things. Now we have some. So let's take position, position, position. So let's take X position. Okay, X component of position as 1, 2, 3, 4, and 5. Okay, and let me take time. Let me take time as 0.1, 0.2, and 0.3, and 0.4, and 0.5. So so at 0.1 the position was 1, 0.2 position was 2, 0.3 position was 3, 0.4 position was 4. So I want to plot this. How can I do it? So what I will do is plot. Okay, plot using this command plot, and then I will do X. This 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 I will use here, and then I will use comma, and I will use time. Okay, so I will use time and I will hit enter. So you can see it has been plotted. So this is time versus position, but I don't know where is time and where is position. So what I will do is I will label the X axis and label Y axis. So label X. I don't know whether this is a format, but let me check. I don't remember, but I hope it is. X. Similarly, we can use Y label as Y label as what? On Y-axis we are plotting X, and on X-axis we are plotting time. Okay. Okay. So again, let me see if can do it. So now you can see that time is there, this T, and see on the Y-axis there is X. Okay, but you may ask that when you hit enter, why didn't this automatically come? The thing was that there was already this figure, previous figures. Okay, if you want that that should not be there, then what you can use is close all. So all the figures which will be there, they will be closed. Now, when I will use this thing. So when I hit enter, so the plot would automatically come. Okay, so this will be X and this will be T. Okay, so this is like so if you know how to create the matrix, you can create the matrix for position. If you know how to create the matrix for time, so you can create time. And then what you will do, you will plot X and T and you will get the position versus time graph for your particle. So this is um, a general idea like what we will be doing. So in next, yeah, any questions? So anyone is raising hand from the tech? Do you have question? Yeah, come to the mic and ask.
Assalamu alaikum, sir.
Walaikum salam.
Sir, does the value change by giving the sir जैसे आपने कहा x position. So अगर हम वहाँ पे y position लिखेंगे तो हमारा ग्राफ वैसे ही change होगा उससे.
Okay, be there, yeah. I will just let me do it for you. So you mean so where? So you mean if I write y here?
Yes, sir. If we put y on this x's place, so will the value change in the graph also? So the place of this value.
Okay, I got your thing. So what I will do is let me change this X position because this is symmetric. If I take time here, so let me take time and use it at the X position. And when I hit in, so see the previous one, okay? See the previous one. So time was here and X was there, but the values, only see the values, 0, 2, and 4 was on the X axis. Now, when I am using time in the time here, oh, sorry. Actually, I was plotting previously position on the X axis and time on the Y axis. Now I am plotting time on X axis and position on Y axis. So now you can see. Okay, so now you can see that time has come on x-axis and that has come on. This was your question?
Yes, sir.
Yeah.
And that why did you use x before the position? So that part. So where you are writing x position, x underscore position. So
Yeah. If
can't
I
we
write
write?
y.
Yes,
Yeah,
sir.
yeah. So you can write anything. It doesn't. Okay, let me do it and see what will happen. So let's take this, copy this and put it here. So instead of x, let me call it as y. It will not make any difference. Why? Because this is just a name. Where the difference will occur is here. When you use plot command, here it will matter. The
Before and
first
after.
thing
The
which,
problem with, sir, yes, the position is dependent on if we write time first or position first,
yeah,
that
yeah,
will
yeah,
create
yeah,
the
yeah,
graph.
yeah. So what comes first will be treated at x as x
X,
coordinate, and what comes next will be treated as y coordinate.
Y, yes, sir. Thank you.
Yeah, it will not distinct whether the name is time or the name is x position. It has nothing to do with it. Okay.
Thank you, sir.
Okay, thank you. I appreciate your question. Any more questions from anyone? Some other guy, this guy was, so I am pointing towards a guy. I think he was raising the hand. Have you any question? See my cursor. Yeah, that one. So you don't have any question? This guy, you are raising the hand. No? Solve? Anyone, किसी और को कोई क्वेश्चन है उर्दू में, कश्मीरी में, जहाँ जिस लैंग्वेज में आप कंफर्टेबल हैं? Okay, so so now you have a lot of things you can do. You can go to your places and first download this MATLAB. If anybody doesn't have laptop, so he can use his friends, or he can also use, I think there is a lab, computer lab, so he can do there. But make sure that from this day you start doing something. Okay, if you think that you will do some other day, you will never do. Okay, keep doing these things small at this time. So you should be able to like write the variable name. You should be able to create the vectors, row vectors, matrices, accessing the elements. Okay. So in next class, what we will do is that whatever we have read, be it the theoretical part or be it like MATLAB, what we have read, we will apply these things to get the simulation of a moving object on a circular trajectory. And you will see that once you have coded, how easy is it to simulate different velocities, accelerations, masses, and other things, and you will be able to analyze the system. Okay. And then we will proceed. Maybe I will take one, two, three problems, simple problems, and then we can proceed. And each day when I will code, I will also send a copy to you so that you can copy paste it. Just I want you to copy paste it on your laptop and run it. I don't want you to code things at this stage of time. I want you to get familiar with how I am using, how I am creating the things. Okay. एक बार आपको वो चीज आ गया तो then you can use your own mind to create the algorithm. But at this point of time, I just want you to copy things, understand what I am doing. Okay. You don't it is better if you can, but मतलब बुरा नहीं मानना है अगर आपको नहीं आ रहा है तो that you can do at this time. I hope you understand that thing. Yeah. One more thing, what I want. Oh, sorry. Just I will stop sharing and I will stop recording. Then I have to say you something. So.